Good morning everyone. Let me introduce myself briefly. My name is Robby Alfardo Irfan and I'm a student of Statistics Department. Thank you to Mr. Asep Saefuddin, Mrs. Yenni Angraini and Mrs. Ir Etih Sudarnika as my supervisors for helping me so much until this time. Thank you to Mr. Anwar Fitrianto as my examiner today. I'm delighted to be here today to talk to you about the analysis of subclinical mastitis in dairy cows using generalized linear mixed model. Let me begin by explaining background information about my research. Nowadays, milk is a good source of many essential nutrients, including vitamins and minerals. Does everyone know about milk production level in Indonesia? That's too bad. Why? Based on Pusat Data dan Sistem Informasi Pertanian Indonesia, in 2016, the milk production level in Indonesia was only able to meet their local needs around 19%, and the other needs, 81%, have to be imported from abroad. I think this graph perfectly shows how is development of Indonesian milk needs between 1990 and 2016. If we look at trend over time, we can see that the imported milk needs increased dramatically in this period, but local milk needs was too stable. What is the cause of low milk production in Indonesia? One of the most common factors is mastitis. What is mastitis? Mastitis is the inflammation of the mammary gland in the udder. Mastitis is the most costly disease of dairy cows occurring throughout the world. How can we detect mastitis? It is indicated by changing in behavior and changing in milk. In behavior, the cows will do less activity, lose their appetite, and be tired easily. In milk, the cows have more somatic cells count and temperature, and the cows have less milk production and lactose in their milk. The source of the infection are these bacteria. There are Staphylococcus aureus, Streptococcus aegypti, Escherichia coli, and many others. How does the infection occur? First, the bacteria enter through the teat opening during milking process, and somatic cells come to rescue from these bacteria. If there are so many bacteria, somatic cells count are not enough to rescue that, it will cause mastitis. There are two types of mastitis, which are subclinical and clinical. Subclinical mastitis does not create visible changes in their milk or the other. Clinical mastitis is characterized by visible abnormalities in their milk or the other. These are the comparison between healthy cow and cow suffering subclinical mastitis and cow suffering clinical mastitis. Look at the teat. The teat is too small and cannot produce milk again. This research used longitudinal data of weekly observation regarding milk production on several cows. What is longitudinal data? Longitudinal data is the combination of time series data and cross-sectional data. Time series data focus on the same variable over a period of time. Cross-sectional data focus on several variables at the same point of the time. And there are some issues of longitudinal data, which are non-normal data and variance among response variables. Based on previous research, Dutt and Cody said that generalized linear mixed models were proposed to unify the regression approach for a wide variety of discrete and continuous longitudinal data and to handle the correlation among response variables. And Ghosh and Ng said that gamma distribution is often used to model such data with non-negative continuous responses that are positively skewed. In this research, we have a continuous longitudinal data with skewed distribution. Therefore, we analyze using generalized linear mixed model with gamma distribution. The main aims of this research are to examine T-tipping that affect the somatic cells count in dairy cows using generalized linear mixed model and to examine somatic cells count and T-tipping that affect the milk production in dairy cows using generalized linear mixed model. The data source is primary data collected from longitudinal research by Mrs. Ir Etih Sudarnika as the leader of that research. The selected individual samples were the dairy cows in normal lactation at the 4th to 6th month postpartum in May until July 2015. The observations were run once a week for 12 weeks with 103 teats from 28 cows in kawasan Pusat Peternakan Sapi Perah Punak, Bogor District. The treatments that the cattlemen gave to the dairy cows were similar in procedures. The treatments were like feeding a cow with a fresh grass twice per day, cleaning the cows and the cage before milking process twice per day, milking process using oil lubrication, animated water availability, and etc. This is the list of variables. There are teeth of dairy cow, repetition, teeth tipping treatment, somatic cells count, and milk production. Procedure of data analysis. First, preprocessing data, cleaning and mixing the raw of data in useful and efficient format. Second, describing data, describing the characteristics of dairy cow in Bogor. Third, analyzing data using GLMM for somatic cells count, using the distribution of response variable, fitting the model, getting the model and estimating the parameter, testing the significance of fixed effect, evaluating the random effect, and interpreting the model. And the last, analyzing data using GLMM for milk production, choosing the distribution of response variable, fitting the model, checking multicollinearity, getting the model and estimating the parameter, testing the significance of fixed effect, evaluating the random effect, and interpreting the model. In this research, the treatment for subclinical mastitis research is teeth tipping. Teeth tipping contains iodine that is essential to control the spread of mastitis organism during milking process. The percentage of doing teeth tipping is greater than not, which is equal to 63%, while not doing teeth tipping is just 37%. Based on this graph, we can see that there are no different pattern clearly between doing teeth tipping and not. We hope that doing teeth tipping has less somatic cells count than not. But the strange things are in the first, 7th, 9th, and 11th week have more somatic cells count than without teeth tipping. If we compare the somatic cells count with milk production, it has different pattern clearly between doing teeth tipping and not doing teeth tipping. Doing teeth tipping give more milk production than not, even though in the 9th week gives almost the same result occurs. The distribution of somatic cells count is right skewed too. Gamma distribution can be used to handle skewed data. If somatic cells count more than 400,000 cells per milliliter, it is indicated that the teeth suffers subclinical mastitis. Based on the data, the median of somatic cells count is 620,000 cells per milliliter. It indicates that more than half of teeth suffer subclinical mastitis. The distribution of milk production is right skewed too. Gamma distribution can handle that too. The maximum of milk production is 6,600 ml per teeth. The teeth mostly produce around 1,600 ml, but the worst case of milk production is until 100 ml. The first analysis is generalized linear mixed model for somatic cells count. Here is the equation of GLMM. There are link function of expected value of somatic cells count using logarithm. Teeth tipping as a fixed effect parameter, ID within cow and repetition as random effects, and random effects parameter. Before estimating GLMM, fitting the model must be carried out using deviance. Deviance can be used to compare how much the model has improved by adding the predictors. Based on the table, deviance of the model has a decreased pattern for adding its predictors. It indicates that adding every predictors has an effect to the model. And we choose the third model with teeth tipping as a fixed effect and ID within cow and repeat as the random effects, because it has the smallest deviance. For estimating, we use the third model. Based on the table of parameter estimation, we can see that teeth tipping does not affect the somatic cells count significantly at alpha 5%. Maybe it happened because some problems that are out of the research control, such as the cattleman did teeth tipping after the end of milking process to all dairy cows, low hygiene in dry season, and the researchers just controlled the teeth tipping once a week. And the interpretation of teeth tipping that the expected value of somatic cells count will be 23% lower for doing teeth tipping than not doing teeth tipping. Random effect evaluation. It's not like fixed effect. We can know how significant the random effect is. We can know just the variance of the random effect. If we look at the table, the variance of ID within cow is quite large. It indicates that the variation between teeth misted cow is quite large. But the variance of the repetition is relatively small. It indicates that the variation within teeth is relatively small. Random effect in GLMM need to be normally distributed. We can see that quantile points of ID within cow and repeat lie on the theoretical normal line. It indicates that random effects fulfill normality assumption. The next analysis is generalized linear mixed model for milk production. I think it is same like somatic cells count before, but the differences are the link function is the expected value of milk production, and adding somatic cells count as a fixed effect. Fitting the model, we can see that the deviance has a decreased pattern too. It indicates that adding predictors has an effect to the model. And we choose the fourth model with cell somatic count and TDPing as fixed effects, ID within cow and repetition as random effects, because it has the smallest deviance. Estimating the parameter using the third model, based on the table we can see that somatic cells count affect the milk production significantly. It is suitable with the theory that the decrease of milk production is linear with increasing somatic cells count, and vice versa. TDPing does not affect the milk production significantly, because in the previous analysis, TDPing does not affect the somatic cells count, and it does not affect the milk production indirectly. Multicollinearity must be checked. Based on the table, we can see that somatic cells count and TDPing have no multicollinearity. The interpretation are the expected value of milk production will be decreased 0.6% as much increasing of somatic cells count, and the expected value of milk production will be 20% higher for doing TDPing than not doing TDPing. Random effect evaluation. Based on the table, we can see that the variation of ID within cow is quite small, and the variation of repetition is relatively small. It indicates that the variation between the teeth nested cow is quite small, and the variation between teeth is relatively small. Both of random effects point lie on the theoretical normal line. It means random effects fulfill the normality assumptions. The next one is conclusion. Generalized linear mixed model can be used to examine TDPing that affects the somatic cells count, and to examine somatic cells count and TDPing that affect the milk production in dairy cows. TDPing does not affect the somatic cells count significantly at alpha 5%. Somatic cells count affect the milk production significantly, but the TDPing does not affect the milk production at alpha 5%. And for suggestion, the researchers pay more attention to the routine treatment such as TDPing every day. And the researchers consider more about the history of cows' disease, the age of cows, and the temperature of cows. Last but not least is references. Those are the references of my writing. Thank you.